Hi, my name is Dr. Nusrat Khalili, and today I will talk to you about water conservation inside your home. This is the second of a series of 4 workshops. My first seminar was on the global water crisis, and you can find a recording of it on our Bay Area Older Adults videos page. The next 2 seminars are about conserving water outside your home and the water conservation rebate programs Valley Water offers to help fund your water conservation projects. The goals of these seminars is to make you aware of the water shortage in our community and around the world and what actions you can take to reduce your water bill and make our community sustainable. This lecture is timely. In fact, 85% of our state of California is in extreme drought. This is a Bay Area Older Adults presentation, which I will call BAO for short. BAO is a nonprofit organization that improves the health and well-being of more than 42,000 adults age 50 plus each year through educational, outdoors, and social programs. For our first question, and to get an idea of how much you already know, on average, how much water on your bill is lost due to water leaks? The correct answer is 12%. Next, I'm going to go over what I'll cover in this talk today. First, I'll give you a bit of background that includes a recap of our global water crisis lecture. Then we'll talk about your water footprint, and that includes the direct water use that you see on your water bill and virtual water use. Next, we'll talk about water use inside your home. We'll cover the major water uses inside your home, some standards for fixtures, and what well-designed products and fixtures look like. Then we'll talk about virtual water, what the concept is, and your virtual water usage. Finally, I'll end with some benefits of water conservation. So now to recap the global water crisis lecture, I just want to remind you that in 2015, world leaders agreed to 17 global goals, officially known as Sustainable Development Goals, or SDGs. It's now 5 years on, and we have more work than ever to do. These goals have the power to create a better world by 2030 by ending poverty, fighting inequality, and addressing the urgency of climate change. Guided by the goals, it is now up to all of us, governments, businesses, civil society, and the general public, to work together to build a better future for everyone. Successful water management will serve as a foundation for the achievement of many of the 17 Sustainable Development Goals, as well as for SDG 6, which is to ensure availability and sustainable management of water and sanitation for all. Next, we covered 6 major water issues. And these were: number 1, we talked about water stress, having sufficient quality and quantity of safe water. Then we talked about number 2, water sanitation and hygiene. This is the WASH goal, WASH, and that is your Sustainable Development Goal 6. Number 3, we talked about water infrastructure deterioration. Number 4, we talked about unsustainable population growth and development. 5, ecosystem destruction. And 6, water-related disasters. Then we focused on water stress, having accessible water in quantity and quality sufficient to meet the population needs. So your water footprint is your direct water use, that is what you see on your water bill, used inside your home and in your yard, as well as your virtual water use. So those are 3 things: indoor, yard, and virtual. Today, we will talk about 2 of these 3 things. We'll talk about the direct indoor use, and we'll talk about the virtual water use. The rest of your water bill is about the yard, and that part we will save for the next lecture. First, let's talk about direct indoor water usage. The big 5 water uses inside your home are: toilet, 24%, shower, 20%, faucet, 19%, washing machine, 17%, and leaks, 12%. We have all heard about low flow in California. What does this mean in terms of standards of products and fixtures? Now, WaterSense is a water efficient product labeling program set up by the Environmental Protection Agency, or EPA, in 2004. California is a state that has faced many a drought and has its low flow requirements for new products and fixtures, and it actually incorporates these WaterSense standards. The other standard I want to mention is MAP, short for maximum performance. And this is specific to toilets. And MAP testing was developed by municipal water utilities industry in 2002 in response to the complaints about the low flow toilets in the 1990s. It is a program to test and rank toilet models based on performance and publish the results for the consumer. So the first big water use is toilet that uses 24% of indoor water use. So that's about 14 gallons per person. Previously, before 1985, the old toilets used 5 to 7 gallons per flush. And that has evolved over time since 1985, so that in January 2016, all toilets sold or installed in California must be 1.28 gallons per flush or less. What you really want is a low water use toilet that performs well, right? Toilets are tested by a third party and get a MAP or maximum performance rating based on their ability to clear solids. When you are purchasing a toilet, you can look up the MAP rating. The Water Sense program requires an MAP of 350 plus, but 600 or so may be a pretty good number, though the numbers do go up to 1,000 plus. So this is the grams of solid that the toilet can clear. The next fixture we will talk about, that is the next big use of water indoors, is the shower head that uses 20% of indoor water. Previously, shower heads had a 2.5 GPM, that's gallons per minute flow, but now the low flow is 1.8 gallons per minute. So 18 gallons for a 10-minute shower. Some people still have baths, and baths use 30 to 45 gallons per bath. The Water Sense label means you should have a satisfying shower because while the flow is low, 1.8 GPM, the shower must have a certain force and it must have a certain coverage as seen in the diagram. This is accomplished by aerating the water or using other technologies in the shower head. The third big use indoors is the faucet. Both kitchen and bathroom are 19% of water use. We all know to not have the water running while we brush our teeth or soap the dishes or utensils by hand. Keep in mind, the current dishwashers are now 5 GPL, that's 5 gallons per load. Since a kitchen faucet runs at 1.8 gallons per minute, running the kitchen faucet for 2 to 3 minutes is equal to running one dishwasher load. The dishwasher is a great water saver compared to washing dishes by hand. The next big water use indoors is the washing machine, 17%. Older washing machines used up to 45 gallons per load, but now we have high efficiency washing machines that use 15 to 30 gallons per load. The efficiency of the machine is measured by a water factor rating, which has improved from 10 down to 8. Next, let's talk about leaks. The average American uses about 88 gallons of water per day. On average, 12% or 7 gallons is lost in leaks. First, you want to know if you have a leak. So you can check the leak indicator. You can check if the meter moves when you have no water running, or you can monitor your bill for changes, or you can use, now they have new technologies, smart leak detectors. If you do find some kind of movement or leak, you want to check if the leak is inside or outside your home. You can put off the water main and see if the meter continues to move or not. If it moves, the leak is outside. Now, let's see what you have learned from me so far. What uses the most water inside your home? Toilet is the correct answer. This is the biggest water user inside the home. Now, I told you I would talk about indoor water use as well as virtual water use. But before launching into virtual water use, I want to take a moment here to digress for a couple of slides, to look at your water bill and touch on the utility company service provider that delivers safe water to our homes. In San Jose, we get a water bill every 2 months that reflects the water we use indoors and in our yards. Water use is measured in CCF, centum cubic feet, meaning 100 cubic feet, where 1 CCF is 748 gallons of water. The pricing structure for water varies from one city to another and depends on your water company's service provider. And you see that on the right of this slide. In San Jose, we have a fixed charge, and then we have a increasing two-tiered charge based on how much water is used. The first tier is 4.5 cents for 10 gallons. And that rate is for enough to meet your minimal basic needs. The second tier is a step up in price, 6.8 cents for 10 gallons. This pricing structure is to get us to conserve water. Now, if you look on the bottom of the slide, the consumption history shows the water that your household used per day. We had 147 gallons per day. While on the subject of the price of water, let's take a minute to ponder this question. Is water a commodity or is it a human right? If water is a commodity, then the water company, a government contractor, must provide sufficient, safe, clean water equitably across the population so everyone, rich and poor, can afford water for basic human needs. Additionally, because of limited supply and increasing demand, they have to price the water to promote water conservation, to protect the environment by water stewardship and holistic management of water resources. Further, since they are a business after all, the revenue they generate has to be sufficient to sustain the utility company in the long term. In other words, the water company has social responsibilities to the individual, to the population. They have environmental responsibilities, and they have fiscal responsibilities. If we treat water as a basic human right, we focus more on the social responsibility to the individual. The United Nations and other countries subscribe to this idea. that water is a basic human right. And the Sustainable Development Goal 6, that is WASH, water, sanitation, and hygiene. If it is a human right, then two things happen. First, it affects the government obligations, laws, regulations, and policies about the provision of safe water. And second, it affects how the public acts. Saying it is a human right empowers the public to act to get the government to fulfill their obligations, to provide water, and to act as change agents. So now back to virtual water. We talked about direct indoor water use. The remainder of your water footprint is made of water you use inside in the yard, as well as, and that's going to be covered in my next lecture, as well as virtual water. So let's get into that. Virtual water accounts for the amount of water that goes into making the food and products you use. Virtual water may be green, it may be blue, or it may be gray, depending on whether it is rainwater, whether it is surface or groundwater, or if it is water that is added to wash and dilute pollution in industrial processes. So, as an example of virtual water, let's talk about a tomato. The amount of water to grow one tomato is 2.5 gallons. The 2.5 gallons is green water if it comes from rainfall on the tomato field. It is blue water if it comes from irrigation. And it is gray water if it is fresh water that is used to dilute the fertilizers and pesticides from the tomato field to bring it up to the water quality standards. Now, besides the tomato, I want to consider some more examples. So next is the piece of paper. So piece of paper, it may take 0.5 to 3.4 gallons of water to grow trees and process the wood into 8.5 by 11 sheet of paper. So using recycled paper can reduce your footprint by 40% because new wood does not need to be grown. Next is your diet. We're talking about your 8-ounce steak that needs 900 gallons of water, most of which is used to grow the corn and grow the soy to feed the cows in those factory farms. Now, it is better for the environment if you eat grass-fed beef over factory-farmed meats and poultry over beef. Now, if we're talking about a pair of jeans, 2,100 gallons of water are needed to grow enough cotton and process it to make a pair of jeans. So these are all examples of virtual water that you use inside your home. Now, if you look at the water usage across sectors in this chart, it shows fresh water is taken from ground or surface water sources used for agricultural, industrial, or commercial and residential purposes. The residential use is just 7%. That's what's used indoors as well as in the yard. Now, the red area of this chart shows the vast majority of fresh water actually consumed is for irrigation slash agriculture, whether to grow corn and soy to feed the cows or to grow cotton to produce jeans. So, how do we know how much water we use directly and how much we use virtually? The water calculator provides a web page where you can input your lifestyle habits like how many times you wash your clothes a week, how many showers you take per week, how much you water your yard, your shopping and eating habits. Based on this data, the water calculator will tell you what your total water usage is or what your water footprint is. While the indoor and outdoor water use amounts to 74 gallons per person per day, this was my data. The rest is virtual water. And of this, the products that you purchase and the food that you eat accounts for a majority of your water use. Factory farmed beef is the worst offender because the amount of water that went into growing the corn and soybean to feed the cattle. So you can see that factory farmed meat is 682 gallons per person per day. So you could make some changes to your diet to reduce water consumption. You could eat less beef, replace factory farmed beef with grass fed beef. Now, the welfare certification labels shown here, which represent more humane and transparent farming practices, also mean that the cattle is grass fed. You could eat less processed food and waste less food. And what effect do we expect this will have? We should have enough water to supply for the growing demand. We should ensure animal welfare and end inhumane conditions in the meat packing plants. Let's see what you have learned so far. What would you use to calculate your in-home water use? The correct answer is your indoor direct water use plus your virtual water use. You may have thought about some of the benefits of water conservation. In general, it saves money. And that's always a good thing. And then it also preserves the environment in several ways. And I've listed just a few of them here. So, my next question to you is, do you plan to make any changes in your life because of what you have learned in this workshop? Please do stay on the polling tab because we'd like to have you rate today's program. Well, thank you again for joining us, and we'll see you at some of our future events. Thanks.